So we will start with Quarter 3, Week 3, Module 3. And we will be talking about proves theorem on the different kinds of parallelogram. Specifically, we have the rectangle, rhombus, and a square. At this point, what are the things that we need to know? Let's start with the different theorems for rectangle. In theorem number 1, stating that if a parallelogram has a right angle, then it has 4 right angles and the parallelogram is a rectangle. Second theorem states that the diagonals of a rectangle are congruent. Next up, we have the rhombus. Theorem number 3, and that is, in a rhombus, the diagonals are perpendicular and they bisect each other. Next, we have the square. That would be theorem number 4. The diagonals of a square bisect each other and are congruent and perpendicular. Now, what are the things that we need to know as we go further with our discussion this time? So, we will talk first, we will have rather activity number 1 called I Wanna Know. The directions we have here is do the procedures below and answer the questions that follow. And these are the following materials that we are needing: bond paper, protractor, roller, pencil, and a compass. So here are the procedures that we have to follow. First, let's mark 2 points OP that are 10 centimeter apart. Number 2, draw parallel segments from O and P which are 6 cm on the side of OP and are perpendicular to OP. Third, name the endpoints of O and P as H and E respectively and draw segment HE. Fourth, draw the diagonals of the figure formed. So this is now the figure formed. So let's take a look with the questions. Question number 1 states that, what is the measure of angle OHE and angle PEH? What did you find it? That is, they are on the same measure. It measures 90 degrees. Second question, what can you say about the 4 angles of the figure? The 4 angles of the figure are right angles. Third, what is the measure or the measure of the diagonals? What did you find? The diagonals have the same length. Does quadrilateral hope appear to be a parallelogram? Why? It is because opposite angles are congruent and consecutive angles are supplementary. What specific parallelogram does it represent? Well, that's rectangle. Now let's proceed to activity number 2. Something more about to know. The procedures, you have it there. In the directions, do the procedures below and answer the questions that follow. Same with the materials that we're needing: bond paper, protractor, pencil, and a ruler. So this is now the time that you're going to work by your own. So let's start with, let's go have it together. Number 1, draw a rhombus that is not necessarily a square. Since a rhombus is also a parallelogram, you may use a protractor to draw your rhombus. Then, name the rhombus NICE, and take note, clarify how rhombus can be drawn based on its definition. Parallelogram, all of those sides are congruent. Okay, are you done? Number 2, draw diagonals segment NC and IE intersecting at point R. Good. Number 3, use a protractor to measure the angles given in the table below. We have measure of angle NIC, measure of angle NIE, measure of angle INE, measure of angle INC, measure of angle NRE, and measure of angle CRE. 10 seconds. And the answer is, we have 70 degrees. And that is 35 degrees. We also have 110 degrees, 55 degrees, 90 degrees, and we have also 90 degrees. Now let's proceed to the questions below. Number 1. Compare the measure of angle NIC and angle NIE. What did you observe? Yes, measure of angle NIC is equal to 1/2 of the measure of angle NIE. You're correct. What does IE do to angle NIC? And why? Well, of course, it's already been there. Segment IE bisect angle NIC. Now, number 3. Compare the measures of angle INE and angle INC. What did you observe? You're right. Measure of angle INE is just 1/2 of the measure of angle INC. What does NC do the angle INE? Why? NC bisects angle INE. Now, question number 5. Compare the measures of angle NRE and angle CRE. What did you observe? You're correct. Measure of angle NRE is equal to the measure of angle CRE. As you look at into the illustration, that's it. Now, number 6, what angle pair do angle NRE and angle CRE form, and why? Perfect. Angle NRE and angle CRE formed a linear pair. How about the diagonals of NC and segment EA related to each other? You're correct. Segment NC is perpendicular to segment IE. Congratulations! Let's now have the definitions. But before that, I'm gonna show you a diagram of a parallelogram. Under parallelogram are the rectangle, the rhombus, and the square. So what is quadrilateral? Quadrilateral is a convex polygon with 4 sides. Diagonal is a segment joining 2 non-consecutive vertices of a polygon. We have here the parallelogram, a quadrilateral with both pairs of opposite sides parallel to each other. Under parallelogram, we have the rectangle, a parallelogram with right angle, while rhombus is a parallelogram with 2 consecutive sides congruent. A square is a rectangle with 2 consecutive sides congruent, and a rhombus with a right angle. So meaning to say, square is just somehow a combination of a rectangle and a rhombus. So let's now have theorem number 1. Theorem number 1 states that if a parallelogram has a right angle, then it has 4 right angles, and the parallelogram is a rectangle. Given that quadrilateral ABCD is a parallelogram with angle A a right angle. Take a look with the illustration on the right. We are asked to prove that angle B and angle C, together with angle D, are right angles. To prove this, we will be using the two-column proof, the statement and the reason. So what would gonna be our first statement? So from the given, of course, the quadrilateral is ABCD is a parallelogram. Angle A is a right angle. Well, of course, our reason is gonna be taken from the given. In that way, we can make another statement, that is, measure of angle A is equal to 90 degrees. The reason is coming from the definition of a right angle. So therefore, angle A is congruent to angle C, and angle B is congruent to angle D. What is the reason? Yes, you are right. In a parallelogram, opposite angles are congruent. So please take note of this. On the other side, measure of angle A is congruent to the measure of angle C. Measure of angle B is also congruent to the measure of angle D. That is the definition of congruent angles. In that way, measure of angle C measures 90 degrees because of the reason transitive property. In number 6 statement, you can have measure of angle A plus measure of angle C equals 180 degrees. By what reason? Remember, in a parallelogram, any two consecutive angles are supplementary. So take note of that. 90 degrees plus measure of angle C equals 180 degrees by substitution. So in number 8 statement, you could have measure of angle B equals 90 degrees because of subtraction property. So measure of angle D is also 90 degrees. That's still transitive property. In number 10 statement, angle B, angle C, and angle D are right angles. That is the definition of right angle. So in number 11, you now conclude that quadrilateral ABCD is a rectangle. That is because of the definition of a rectangle. So example number 1. Why do you think the definition of a rectangle does not state that all 4 of the angles are right angle? As you can see in the illustration, why? Yes, you are right. Using the properties of a parallelogram, if angle A is a right angle, then angle B is also a right angle. Because angle A and angle B are supplementary angles, the same reason will prove that angle C and angle D are also right angles. Now let's proceed to theorem number 2, stating that the diagonals of a rectangle are congruent. With the given, quadrilateral ABCD is a rectangle with diagonals AC and BD. So as you can see in the illustration, it's there. Okay. We are asked to prove that segment AC is congruent to segment BD. We are now already given with the two-column proof. What we need here is we are going to supply what is missing. So in our first statement, it says there that quadrilateral ABCD is a rectangle with the reason that is given. And second statement, segment AD is congruent to segment BC. That is because in a parallelogram, opposite sides are congruent. So remember that one. Take note of this. So statement number 3, angle D and angle C are right angles because a rectangle has 4 right angles. So therefore, measure of angle D and measure of angle C is congruent because any two right angles are congruent. That segment DC is congruent to segment DC because of the property called reflexive. So for number 6 statement, you could have triangle ADC is congruent to triangle BCD. By what reason? SAS postulate. Side, angle, side postulate. As a conclusion, segment AC is congruent to segment BD. And that is CPCTC. Corresponding parts of congruent triangles are congruent. Let's take for example, given quadrilateral BEST is a rectangle with segment ST measures 24, segment BT measures 7, and segment BS measures 25. And we are asked to find segment ES, BE, ET, and measure of angle BES. Okay, 10 seconds. Okay, so the answer is segment ES is 7, 24 CBE, segment ET is 25, measure of angle BES is 90 degrees. Is that clear? Let's now proceed to example number 3. Quadrilateral PICK is a rectangle. So take a look with the illustrations at the right. What kind of triangle is triangle KOC and why? Where is KOC? So the answer is triangle KOC is an isosceles triangle because segment OK is congruent to segment OC. Remember when you say isosceles triangle, two sides of a triangle are congruent. So that's why segment OK and segment OC are congruent. Therefore, this triangle is said to be an isosceles triangle. Next question. What kind of triangle is triangle PIC and why? Anybody? Yes, that's correct. Triangle PIC is a right triangle because angle 1 is a right angle. Next, if segment PO and segment segment OI equals 50, what is the measure of angle segment PC? Yes, PC measures 50 also. Correct. So letter D. Name all pairs of congruent segments in rectangle PICK or PIC. So we have segment IPI or IP, you could have it there also, and segment KC, segment PK and segment IC, segment PO and segment CO, segment IO and segment KO. Now let's proceed to theorem number 3. In a rhombus, the diagonals are perpendicular and they bisect each other. Okay, with our given, quadrilateral ABCD is a rhombus. So as you can see in our illustration, okay, we are asked to prove that segment AC is perpendicular to segment BD. Still, we're going to supply what is missing in our two-column proof with our first statement that quadrilateral is a rhombus with a reason that is given. Our second statement, what would gonna be with our reason nga definition of rhombus? That would be segment AB is congruent to segment BC. But still remember the properties of a rhombus? So, in number 3, BQ or segment BQ is congruent to segment BQ because it is reflexive property. Now, what would be our fourth reason with our statement nga AQ is congruent to CQ? Yes, in a parallelogram, diagonals bisect each other. So remember that one. The diagonals bisect each other. In number 5, triangle ABQ is congruent to triangle CBQ because of the postulate, SSS postulate, which means side, side, side postulate. Now let's take a look with our example number 4. Given that quadrilateral CORE is a rhombus or quadrilateral core, we have here the question, is CL congruent or equal to RL? Or is EL is congruent to OL? Can you see that? Yes, because diagonals of a parallelogram bisect each other. So they're just congruent. So second question, which triangle in the quadrilateral core are congruent? Why are they congruent? You're right. Triangle CLO is congruent to triangle OLR and congruent to triangle RLE, so with triangle ELC, because they can be proven by SSS postulate, SAS, ASA postulate, the HL theorem, the LL theorem, and LA theorem. So let's now proceed to example number 5. Given quadrilateral HINT or HENT is a rhombus. So what are the characteristics of the quadrilateral HENT? Perfect! Quadrilateral HENT is a parallelogram with all the properties of a parallelogram. And also, HN is perpendicular to segment IT. And HN or segment HN bisects angle INT and angle THL. Because IT bisects angle HIN and angle NTH. Now let's proceed to example number 6. Given quadrilateral ABCD is a rhombus, and we are asked to find the measure of the numbered angle in the given figure. So we have here the illustration of the given figure that segment AC bisect segment BD, and segment BAC measures 50 degrees, and we're looking for the measure of angle 4, 3, 2, and 1. So let's start with the measure of angle 4. Okay, so measure of angle 4 will be equal to 90 degrees since the diagonal of a rhombus are perpendicular. Okay, now if you're going to find the measure of angle 2, that would also be equal to 50 degrees. Why? Because that angle there will be congruent to the angle BAC. Because segment AC will be considered as the transversal line as we are going to extend further segment AB and segment DC. Two parallel lines cut by a transversal, then alternate interior angles are congruent to each other. Now how about measure of angle 3? That will also be equal to 50 degrees since Each diagonal of a rhombus bisects two angles. Lastly, we have measure of angle 1, which will be measured 40 degrees. The acute angles of a triangle are complementary. Let's proceed to theorem number 4. The diagonals of a square bisect each other, are congruent and perpendicular. Given quadrilateral ABCD is a square, let's take a look at the illustration. We are asked to prove that segment AC is equal to segment BD and segment AC is perpendicular to segment BD. What we have here are the two-column proof with the statements, and we'll just supply what are the reasons. So for number 1, very clear, that is given. Okay, so number 2, definition of a square. Number 3, definition of a square. And number 4, reflexive property. Yes, you're right. Number 5, that is SAS postulate. How about number 6? CPCTC. Corresponding parts of congruent triangles are congruent. How about number 7? Yes, that's very good. The diagonals of a square bisect each other. Number 8, definition of a square. Yes, very clear, reflexive property. In number 10, triangle AOB is congruent to triangle AOD. SSS postulate. How about number 11? You're right, CPCTC. Yes, these two angles form linear pair, and linear pair angles are supplementary. That's why angle AOB plus measure of angle AOD is equal to 180 degrees. So you're going to combine, that is addition property. Then you will have the division property. So angle AOB is equal to 90 degrees. That's division property. And therefore, definition of perpendicularity. Segment AO is perpendicular to segment BD. Or segment AC is perpendicular to segment BD. So you have proven it already. At this point, let us enrich more knowledge. You will be the one to answer. Here we go. Exercise number 1. Exercise number 2. Exercise number 3. Exercise number 4. And now, let us proceed to activity number 3. This is made especially for you. Here are the questions. Next up, we have activity number 4. Now let's have the summary of the different properties of a rectangle, square, and a rhombus. So let's start with the properties of a rectangle. So it says that opposite sides are congruent, opposite sides are parallel. Each diagonal separates the rectangle into two congruent triangles. Opposite angles are congruent. Consecutive angles are supplementary. And lastly, all angles are right angles. So we have the properties of a rhombus. All sides are congruent. Opposite sides are parallel. Each diagonal separates the rhombus into two congruent triangles. Opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect each other and are perpendicular. And lastly, we have each diagonal bisects a pair of opposite angles. Now let's proceed to the properties of a square. All sides are congruent. All angles are right angles. Each diagonal separates the square into two congruent triangles. There you go, the properties of the rectangle, rhombus, and a square. So let us now have the post-test. Letter A. Answer the following with always true, sometimes true, or never true. Letter B. Name all the parallelograms that possesses the given. Once again, this is quarter 3, week 3, module 3.